So let's do an example of standard deviation. If you remember, standard deviation is basically how much each score varies from the average score. So we would calculate that off of the variance, but it would look like this. Where basically the standard deviation here equals the square root of the sum of x, all the x minus x bars squared, divided by n, which is the number of cases or data points. So let's work an equation. We've got the following numbers in our data set here: 9, 6, 8, 4, 2, and 1. Now the first thing that you're going to have to calculate when you do standard deviation is the average of those scores. So that x bar is what we call the average or the mean. And in this case the mean is 5. So let's take those numbers, keep those numbers handy, and to work out this, it looks like a complicated equation, but to work out this equation you can draw a simple chart. And we'll just do everything step by step. The first thing that you'll do in this column that I have marked X is write out each of your data points. 9, 8, 6, 4, 2, and 1. Now this next column that says x minus x bar, we're taking the x, which is everything in that first column, and subtracting the average or the mean from it. And if you remember, we already calculated the mean, so you'll take each one of those x's and subtract 5. So for the first one we'd have 9 minus 5, which is 4, and then 8 minus 5, which is 3, 6 minus 5, which is 1, 4 minus 5, which is negative 1, 2 minus 5, which is negative 3, and 1 minus 5, which is negative 4. Now the first thing that I want to do is kind of remind you that when you see these negatives, we're kind of treating these negatives while we're doing this equation like they don't exist. So when we square it, don't worry about those negatives. We're just going to be squaring these numbers. So this next column, x minus x bar squared, we already figured out x minus x bar is 4, so 4 squared is 16, 3 squared is 9, 1 squared is 1, 1 squared is 1, 3 squared is 9, 4 squared is 16, and we filled out our column. We've done the bulk of the work, and as you do this work, we went through this rather quickly, but use a calculator, go step by step, make sure you don't make any mistakes, because one error in any one of these calculations is going to throw off your calculation for standard deviation. So our next step is to add up this column right here, because remember we're doing the sum of all the x minus x bar squared. So add up all of these numbers, and that actually comes to 52. And we will take this number 52 and we will begin to put things into our big standard deviation equation. So we'll write the standard deviation equation again here at the top. The sum of all the x minus x bar squared over n. So S equals the number 52 that we just calculated with the column. That's what this is right here. That's all that this is on the top, is the chart, the number that we just calculated from the chart. So again, 52 divided by n. And again, n, if you remember, is just the number of cases or the number of data points. And remember, our data points were 9, 8, 6, 4, 2, and 1. So we actually have 6 data points here. So our next step will be to divide 52 by 6, which is 8.67. And then we will take the square root of 8.67, using your calculator again, don't be intimidated, and that comes to 2.94. So our standard deviation is 2.94. What does that mean for us? For our data set that we have here, 9, 8, 6, 4, 2, and 1, the average, or the mean, that we symbolize x bar, is 5, and our standard deviation is 2.94. So basically, each score, each individual score, so each one of these right here, is relatively close to the mean or the average. So we don't have a lot of variation in this data set. You can tell by looking at it that there's not a lot of variation in this data set. They only range from 9 to 1, that each data point. So there's not a lot of variation, so our standard deviation is going to be small, just like it is here, small, 2.94. You may kind of wonder, well, why do we need to have an equation to work out something that we can see with our eyes? We can see that these numbers are relatively close together and that they're relatively close to the mean 5. Well, typically in a data set you're going to have hundreds if not thousands of data points, and you're not going to be able to easily look at each one of those data points and to determine how many are close together and how many are close to the mean. So the standard deviation will help you determine basically the spread of this data. How close are all of these data points together? So that is our explanation of standard deviation.